Hello students. So in this video, I will be your guide and walking you through the steps to create your capstone projects in our data science fundamental course. Here I have taken one sample project, a capstone project. The title for this particular project is Fandango movie rating discrepancy analysis. So if you want to know about this particular project, back in 2015, there was an article published mentioning that be suspicious of online movie rating, especially the Fatingo website. The article states that they are overrating their movies. Basically, this Flatingo is a website where they will sell movie tickets, like how we are having Book My Show here. Similarly, there is a website like that. So in other words, if you want to say means the number of ratings that the website shows for a certain movie is often higher than the true rating of the same movie. So to increase the sales, what they have done is they have increased the ratings of particular movie to sell their tickets. So which has been found and that became an analysis. So here, what problem we are actually trying to solve is if you are planning to go out to see a movie, how well can you trust online review and ratings? Especially if the same company showing the rating also makes money by selling movie tickets. Do they have the bias towards the rating movies higher than they should be rated? So for that only we are going to do some analysis and we are going to find okay how they have been misusing the ratings and all. So here we have taken two data set. So first data set is all sites score.csv. So in this data set different sites how they have rated a particular movie. So that list has been given in the CSV format and for the same movies how they this particular website has given the rating, how high the rating is. So based on this data set only, we are going to perform some operation. So when you are doing your own project, you also have to follow this steps. Any project you can take or you can do the same project what I am doing also. And if you want the data set which I am using, it will be available in a website called kaggle.com. Okay, in the kaggle.com, you can find the data set. If you are typing movie review analysis like that, if you are typing or if you are mentioning like a Patango movie rating means it will show you how to download the data set. Okay, once you have downloaded the data set means place your data set in the same folder where you are going to keep your program file. Okay. So one by one, I will explain you like how we can perform each and every operation. First, first step is going to be import any library you think you will use. Okay, so this project is completely going to be based on whatever uh, we have learned in all this 8 weeks of the program. So we are not going to do anything new. So whatever we have learned previously as a concept, we are going to apply all the concept into the real time and we are trying to solve this particular problem. The first task is we have to import the whatever libraries we needed. So I am going to import. So I'm importing the NumPy library, then Pandas library. Then for visualization, I'm importing the matplotlib. Then Seaborn again for visualization purpose. Okay. Then our next step is exploring the Fatingo displayed score versus true user rating. So in that first task is going to be, so we have to run the cell to import the particular CSV file. So the Fandango scrap.csv file I want to import. So for that, what I'm doing is I'm creating a variable called Fandango. Okay. So pd dot read underscore CSV. So in that, I'm giving my file name. Okay. So I have imported the file. Then I want to see my file. Okay. What are all the data are present in my particular file? I want to check. For that, simply I'm just giving the variable name dot head. So if you are giving without passing any parameter means by default it will return 5 rows. First 5 rows it will return. So we can able to see what are all the columns are there and what are all the datas are there based on that particular column. So film names, what is the stars rating, and then votes have been given. Then if I use the info method, so it will return me the column names along with what data type it is having. Okay. Similarly, I can use the describe method also. So this describe method will take only the numerical column and it will return the count, mean, standard deviation, minimum value, maximum value, what is 25%, what is 50%, and what is 75%. Then we have to find the relationship between the popularity of the film and its rating. So for that, so I am creating a scatter plot here using the Seaborn library. I'm passing the data set and I'm giving the X value as rating and my Y value as votes. So this is how I will get the plotting. Okay, I have used this scatter plot here. Rating versus votes. Then I am planning to create a new column that is able to strip the year from the title strip and set this new column as year. So for that, so to create a new column, simply we have to give the variable name. In the square bracket, we have to pass the new column name. The new column name, I'm giving it as year. And then to find the year value, I'm just taking the film column. So in that, I'm applying some function. Okay, so apply title, which is title dot split. So in that -1. So if you are giving -1 means it will take the last value. So we know Python is having a reverse index, right? So if I give -1 means it will take the last index value. Okay. So now a new column has been created. So to find how many movies are there per year means simply I just have to call the function column name. So dot value underscore counts. So if you give this means it will return how many films. So in 2015, how many films? 14, how many? 16. Okay, like that it will return the values. Then our task is to visualize the count of the movie per year with the plot. So for that again I'm using the Seaborn library. Here I'm going to perform the count plot. And I'm going to count the data of my data set. And here X is going to be my year. So as you can see, 2015 is having the more count when compared to other years. Then we are going to find what are all the 10 movies which is having the higher number of votes. So for that, what we can do is the data set dot, we can use a method called n largest. So in that we have to pass how many largest value you want to take. If I give 5 means top 5 it will show. If I give 10 means top 10 it will show. Of votes we need to see, right? So top 10 votes I'm going to see. So these are all the top 10 movies rated. Okay. So it's like starting from 3.5 to, top 5 rating, 5 out of 5 rating also it has got based on the vote we have taken. Then how many movies have zero votes? Okay. If any movie is having zero rating means we can able to find that. So for that, I'm creating one variable like no votes. So in that, I have to take the vote column alone. In that, I'm just comparing. Okay, equal to 0. If anything is there means I want to know the total value. So I will give no votes dot sum. Will give the return value. So 69 is having 0 votes. So for 69 movies, there is no any voting given. Similarly, if I want to create a data frame of only reviewed film by removing any movies that have 0 votes. So I want to remove all the movies which is having 0 votes and then remaining movie only I want. Okay. So for that, what I will do is I will create another one variable like fan reviewed is equal to. So again, I have to take the vote column. In that, I have to check values greater than 0. Okay. So now if I run this means whichever movies having votes more than 0 will be stored in the fan reviews variable. Then I'm going to create one KDE plot. Okay. For that, I'm just writing the following code. So again, Cbond in Cbond library, we are having KDE plot. I'm passing the data. So now I'm going to pass the fan review data alone. So here I'm going to give the X value as rating. So fill attribute, I'm just giving it as true. And then label, I'm giving it as true rating. Similarly, I'm creating another one KDE plot. Again, I'm passing the data as fan revised. Here, the x-axis is going to be star. So remaining all and all are going to be the same only. Here in the label, I'm going to give stars displayed. Okay. For the previous KDE, we have given true rating. And here I'm going to give the label as star displayed. And finally, I'm giving. So you can able to see the color different. So blue color represent the true rating and this light orange color represent the stars displayed. So in the x-axis we are having the rating and y-axis we are having the density part. Then our next task is going to be, so now we have to actually qualify this discrepancy. So how much discrepancy is there? We have to find. So for that, what we have to do is we have to create one new column. In that new column, we will find the difference between the stars displayed versus true rating. So we can able to see some differences there, right? So when compared to the stars display, true rating is very high. So we are going to find the difference and we are going to create one new column. So for that, in the fan review itself, I'm creating one new column and I'm naming it as stars different. Okay. So fan review in that star column I'm taking and I'm subtracting with rating column. Then we are having fans review. So in the stars difference, we will be getting some decimal values, right? So I'm just trying to round it off to two decimal values. So for that, dot, I'm using the function called round of two. Okay. Then If I run and check my fans review, so this is how you can able to see one new column has been created and the difference are stored here. So we have given round to 2. Okay, so it will take up to 2 values only after decimal. Then we have to create a count plot to display the number of times a certain difference occurred. So if there is no any difference between the rating and the stars, then it will return like 0.0. So how many times there is a difference occurred here? 0.2 is there, here 0.1 is there, right? I want to find how many difference happened in each these two columns. So for that, I'm again creating one count plot. So here X, I'm taking it as stars different. I'm going to use the palette as magma. So you can able to see how much difference it has occurred. So 0.0 means there is no any big difference between the actual value and the star value. Here 0.1, 0.2, 0.3, 0.4, 0.5, up to 1.0 is there. 1.0 is very less when compared to other differences. So we can see from the plot that one movie was displayed over a 1 star difference than its true rating, right? What movie had is close to 1 star difference? So that particular movie we need to find. So for that, what we can do is simply we just have to filter based on our condition. So our condition is we have to find star difference value which is equal to 1. So for this particular movie, Turbo Kid movie alone, there is one difference is there. See, actual rating 4.0 is there, stars given is 5.0. Oh. So now we are in the third step. So in the third step, what we are going to do is comparison of Fandango's rating to other sites. So far we have analyzed the Fandango ratings. Now we have to compare it with other sites as well. So for that, first what we are doing is we are importing the second data set. So I'm giving a name to my data set, all sites, then pd dot read underscore csv. So in that, I will just give the okay. So now I have imported it. Then what I'm going to do is explore the data frame columns info description, like how I have done for the Fandango data set. Similarly, I have to do it for this as well. So simply I'm just giving all. So in this, we are having like many columns we are having. So each column name and what data type it is having, we can see here. Similarly, we can also use the describe method. Okay, so we have used the describe method as well. So now what we are going to do is we are going to create a scatter plot. So for this particular data frame, again, we are going to perform some scatter plot here. Plot figure. So here data we are taking all sides, and x-axis I'm going to give rotten tomatoes, and y-axis I'm giving it as rotten tomatoes users. Then I'm providing the x limit and y limit. So limit I'm giving like 0 to 100. Similarly for y limit, I'm giving 0 to 100. So column names, we have to give it correctly. Okay, it is case sensitive. That is why we got that error. So I have resolved it. So we have to give wherever caps is coming, we have to give caps. Small is there means we have to use this cap. So this is the scatter plot output. Then we are again for this particular data set, we are going to create one new column. So here we are going to find the difference between the critics rating and the user rating, because usually critics will give a different rating and user will give some different rating, right? So that only we are going to find out what are the difference. So for that, taking the rotten difference. So I'm taking the rotten tomatoes minus rotten tomatoes users. Okay. Now I'm going to calculate the mean absolute difference between the rotten scores and rotten tomato user scores. So for that I will be using, I have to take the column rotten difference. So in that I will be using the apply method, and I will pass absolute value. I want only the absolute value, and I will find the mean for those absolute value. Because there is some possibility that we will get negative values also when we are performing the difference operation. But I want only the positive value. So I will convert everything into positive value, and then I will find the mean for those values. So if I run this means, sorry, here I have given 2 times t, that is why it is showing error. Now I have resolved it. So the difference is going to be 15.09 like that. I'm getting the difference. Then what I'm going to do is I'm going to plot the distribution of difference. So we have found the difference, right? So I'm going to plot it and I'm going to use that histoplot method. So let us do that. So again, in the Cbond library only, I'm taking this histoplot data. I'm taking the all sides. So for x-axis, I'm taking the rotten difference column. And then KD, I'm giving it as true. Then title for that particular plot, I'm giving it as RT critic score minus RT users score. Okay, so this is how my histoplot will look like. So bottom values has been given. So it is ranging from -60 to +40. And left side, you can able to see in the y-axis, we can able to see the count. So it is getting increased and decreased. Now we are going to find the differentiation based on the absolute value between these two columns. So for that, so here in the x-axis from the all sides, I'm taking the rotten difference column alone. Then I'm applying that absolute apply ABS. Okay, here I'm not finding any mean and all. Okay, only the ABS I'm passing. So whatever values I'm passing, if you are giving as it is means we can able to perform this operation without any error for this particular project. If you are doing any other project means accordingly you have to change the value. Okay, you can do any analysis based on what you have learned. You just have to give the close bracket. Okay. Small mistake only. Here I have opened the bracket. Okay, here instead of closing the bracket, I have given the DPA equal to 200 inside. That is why it showed error. Okay, now I have resolved it. So we got the output. Like that, whenever you are doing means if you are getting error means just check by seeing the error itself, you will get some idea. Okay, where you have made mistake. Maybe if you have opened a bracket, you forgot to close it, or you have given the data wrongly, or you forgot to give the comma. So those things we have to check whenever you are getting an error. Then what we are doing is we are going to find the top 5 movies. So for that, we are just giving heading like in the print statement. Users love that movie, but critics don't like it. So those type of movies we are going to take. So for that, all sides. So like how we have used n largest. Similarly, we are having n smallest. So in that, I'm giving. I want five movie names from the Rotten difference, and I am also specifying it with film and Rotten difference. So these are all the five movies which are loved by the user but hated by the critics. Then now we will show top five movies critics score higher than user on average. Like critics like the movie, but user didn't like that movie as much. So just giving an heading like critics love, but users hate. Same way. Here I have to use n largest at 5. So remaining and all going to be same only. Okay. Just copy this. Okay. So these are all the movies liked by the critics by but not liked by the users. Then we are trying to display a scatter plot for the Metacritic rating versus Metacritic user rating. Okay, again we are trying to perform some comparison operation using the scatter plot. So data I'm taking all sites. In that for X, I'm taking the Metacritic, and then for Y, I'm taking the Metacritic users. So for this also, I'm giving the X limit and then Y limit. So we have performed the scatter plot for Metacritic and Metacritic user. Right, change. So values are ranging from 0 to less than 20 only is there. So Y limit I don't need up to 100. So I'm just changing it to 10 only. Okay, now we can able to see the scattering, how much it has been scattered. Okay, not more than 10 values there. So only few is having 10. Okay, mostly ranging from 4 to 6 like that. It is ranging less than 4. Only few data are there. So similarly, IMDb rating. So again, we are trying to create one scatter plot to find the relationship between the vote counts on Metacritic versus vote count on IMDb. Okay, the Metacritic how much rating we got and IMDb how much rating we got. So we are trying to compare again. So all these columns are already there in our data set only. So if you know the column names, we can simply start giving them. Here, all you need to do is check the spelling. Okay, and the cases you have to check whether they have given uppercase or lowercase. That we have to check, and we have to give it correctly. Okay. See some values. It is very far from the actual values. Okay, these are all we called as outliers. So we are going to find that one movie alone. Okay, what is that one movie alone? It is completely far away from other ratings. So to find that, we are using that same n largest method, that one. Okay, first movie alone, I need to know from which column, that IMDb column. So this movie, the Intimation game 2014 game movie that is having the highest IMDb user voting count. So what movie is having the highest Metacritic user voting count? For IMDb, this is the movie. For Metacritic, how to find us? Same way. Here only we have to change the column name alone. So I'm just copying this. Here just change the column name to Metacritic user vote count. So Mad Max Fury Road 2015. So this movie only got the highest rating in Metacritic. Now we are going to compare the Fandango score versus other side score. So for that, I'm going to merge. So I'm going to use a method called merge from the Panda library, and I'm merging the Fandango dataset and all sites dataset. And I'm storing it one new variable called df. Okay. On what basis I'm going to merge this? Based on the film column from and how I am going to merge this? Inner. So in join, we are having different types of join is there. Inner join, outer join, left join, right join is there. Here I'm going to use the inner join method. Okay, now if I go and check my data set in. So these are all the columns and data types, not null value count. Okay, everything has been given here. So if I want to see the data set means just simply I will give header. So these are all the columns and values. So now we are trying to normalize the columns to Fandango stars and rating 0 to 5. So we are going to convert 0 to 5 ratings. Okay. So first we are going to create a normalized column for all the ratings so they can match up with within 0 to 5-star rating shown on the Fandango. So there are many ways we can do, right? So we can perform any one method and we can do that. So for that, what we are doing is so we are creating new columns and we are adding the new values. So I'm just giving less RT. So we are normalizing the data, right? So to represent the rotten data, I'm going to normalize. So np dot round, taking the rotten tomatoes data set and I'm trying to divide it by 20 and the round of value I'm taking up to one value only. Similarly, for rotten tomatoes user normal, same thing, only the column name is going to change. Just need to give underscore user. So this is for rotten. Similarly, for meta, same operation we are going to do. Simply again, column names are going to change. Okay, simply I'm just copy pasting and I'm changing my column names alone. So if you are following along with me means make sure you do it correctly. Okay, while copy pasting, don't do any mistake. Where and all I'm making the changes, try to do the changes. So here, this alone we have to divide it by 2, not by 20. Similarly, I have to perform the same thing for IMDb. Okay, IMDb also I have to normalize to fatting or rating. So for that, so that values also I have to divide by 2 only. And the column name is going to be IMDb. So now if I check my data set, df.head, so all the new columns will be added and it will be converted to 0 to 5 ratings. Okay, all the normalized columns have been added here. So this will make us to easily compare with the previous data set. So now what we are going to do is we are going to create a normal score data frame that only contains the normalized rating because now no longer we need the old ratings, right? So whatever normalized column we have created, that alone we are going to separately take and we are going to put it in one new data set. Okay, so for that I'm just giving a variable name as normalized score, which is equal to df. Okay, in that whatever columns I needed, I just have to mention their names. stars. Then I want the rating. Then I want RT norm, meta norm. So when you're typing it, make sure you give the correct spelling, everything. You just check it once or twice before running that particular cell. Okay, so these are all the columns I needed. We have made some mistake here. Let me just check what mistake I have done. Okay, instead of giving meta, I have given metu u norm. Okay, that is why there I got the error. Okay, simply I will just change it to meta. Now if I run this means new column will be added. Okay. So now without any error, this line got executed. So now I can go and check my data set. So all the required columns alone I have created as a separate data set. So now I have to compare the description of the scores across sites. Let me just compare it. So for that, I'm creating one function. Okay. So for your understanding only, I'm just typing each and everything line by line. Okay, instead of just copy pasting all the codes needed. So while you are practicing, you can also understand, okay, each and every line what we have to type. So now I'm going to use this subplot method. Okay. So I'm counting the plots here. So we can able to see different colors we are getting for different plots. Okay, what is the actual rating? What is the Rotten Tomatoes normalized rating, Meta rating, and then IMDb rating? So everything. So you can able to see from this output itself, there is lot of difference between each and every values. Okay. So now we will create one KDE plot to compare the RT critic rating and then the stars rating given by the Fandango website. For that, taking the RT norms and then the stars. So this is the comparison between the RT norms and the stars value. Similarly, if I want to perform the histogram comparison for all normalized scores. Okay, so for that, what we can do is can use the subplot method and then the histogram. Okay, fixed size equal to. So using the histogram chart, I am just analyze the ratings of each normalized score. Then how are the worst movie rated across the platform? So there will be some worst movies, right? So just to increase the rating, what and all they have done. So for that, we are using one different visualization chart here. We are using the cluster mapping method. Okay. Again, this cluster mapping is also available in the Seaborn library only. So all these are like advanced libraries. We map. So this is how the cluster plot will look like. So where and all the I mean black color like that you are seeing means one rating, 2, 3, 4, 5 like that. The values have been changing here and there. So then our task is, so clearly we can able to see that Flatingo is rating movies much higher than the other sites. So especially considering that it is then display a rounded up version of the rating. So let's examine the top 10 worst movies. Okay, best movies we will not know, but we will take the top 10 worst movies. So and then we will try to compare it with other sites rating as well. Okay, so we are just trying to filter the data. So for that, from the data DF data set, we are going to take the required columns alone. DF, in that whatever columns I want. Stars, then rating, then RT norm, then again meta norm, underscore norm. So we have created one new data set, norm films. So in that, I am going to take top 10 worst movies list. So to get that, what we have to do is simply we are just have to use the n smallest dot n smallest 10 movies based on the RT norm. So these are the 10 worst movies. Okay. So finally, we are going to visualize the distribution of the rating across all the sites for the 10 worst movies. So how the data has got distributed for all these 10 movies. So here we are using the KD plot method only again. So data we are taking the worst films. Then we are giving some title to our plot. So title like ratings for RT critics for the 10 worst reviewed films. So here we can able to see it clearly, like for different movies, how they have given the ratings. Stars, it is in one color, rating is in another one color, RT norm, meta U, IMDb norms. Okay, all they are having like different ratings, and this green color is very high for the different movies. And similarly, for some movies in IMDb norm, they have given some high rating, and for some movies they have given high rating for in the meta norms. This rating and then stars more or less same for most of the movies. So in this way, we can perform all the analysis. So what and all we have done. We have first taken one data set and we have performed some operation. We have added some column and we have performed some visualization in that particular column. We have done some comparison operation. Then we have taken another data set. So in that data set, again, we have performed some operation. Then we started comparing two data set values and we have filtered only the required data set. So like that, lot of things we have performed in each and every places. So in this way only, you have to do your own project. Right, it can be any project of your wish. So here I have taken one sample project and I have tried to execute all the program like step by step I have executed. So if you are planning to do the same project means you can follow the same uh, code and you can get the similar output.